Hello everybody, welcome to another video of learning malware analysis with PackT. In this video, we're going to look at how to detect packed malware. In this particular video, we're just going to see some strategies that we'd use to detect any malware that has been packed. So just to make it easy, we're going to use some very common methods. The first one is using statistical analysis tools, byte histograms, and also just checking the PE headers. So if we look at looking at our malware samples, let's combine looking at headers together with using statistical analysis tools. So let's look at unpacked malware and we can just have a basic look. So what we'd see is that first of all, it's very easy to tell even what was used in development of this particular malware. If we go to the section headers, we see we have a regular text and data section, which is unhindered from our view. If we look at our import directory, we can see exactly what we need, and we can see some of the functions that are actually used by the malware. Let's see how that changes with a packer. The first packer we look at is called Empress. So when we look at the section headers, we notice there's a modification of headers. That's the first thing. If we look at the basic data, we see that there is no identity given for the particular language used to develop the application, for instance. Again, as you see, it's already obscuring a lot from us. If we go to the import directory, we can see only the two imports, the kernel32 and MSVB, but we do not see the functions within. As you notice already, the intent is hidden. If we look at another one, we'd notice is called UPX. So with UPX again, we notice it does advertise in this case, but not necessarily does it do that always. Although some of the key things to look at is the consistency of, again, the data sections and the text sections have been replaced by UPX0 and UPX1. Now another thing to look at is the modification of the input functions. As you notice, a similar result to what we saw with the Empress. However, we notice that the imports used are different. So there's a strategy here used where we can see that it's calling virtual allocation. Now we can use some of these functions that have been released, or rather to actually capture the essence of the packer and trace it to the unpacked stub. The unpacked stub is simply an area in memory where a packer will have decompressed the malware. Now at that point, we will be able to see its true intent. So next, let's look at something interesting, which is byte histograms. So we'll just use a tool called bytehist, and it's really a simple tool. You never give it an extension, so let's just do that again. Byte histograms tell us a bit about malware from a perspective of the byte frequency. So as you can see, this is an unpacked malware. The text section and the data section are what we see with modifications most of the time. So in this particular case, there is no modification, and this is what the byte histogram looks like. So this is the data section. Ours is a flat line. So let's see what happens when we do the same with packed malware. So again, this is quite key. So we can test with Empress. So again, testing with the Empress. Let's look at that. As you can see, the compression has really changed elements. So this is ideally the text section, which is what we're calling Empress 1. As you notice, the byte histogram shows that there's quite a lot of compression activity, which shows that the byte allocations are really more compressed. So there's more activity in this sense rather than our flat line. The same should happen in the data section. As you can see, our initial data section was a flat line. However, in this case, it's not anymore because there's more to be compressed. That's another way of looking at it, and at the end you can actually detect packing using that method. So I hope this has actually enabled you to understand some of these key ways we use to identify packed malware. They're really simple, and packed malware has really very many indicators, but those are the most common, and it's quite applicable. As you've noticed, we've used two different packers in this case, and both packers resulted in similar modifications, which we could tell with just very basic tools. So most of the other packers still follow the same process, where you'd notice things from the onset that packing has been done.